Okay, hi, we're ready for Solubility 2, that's Prac 5, and I'm doing this because I'm picking that you don't have iodine at home. Iodine is the stuff that those old enough to remember will be that the nasty lady in the playground would paint this on cuts and scrapes, but now it's considered too dangerous for that kind of carry on. So here it is, and hence the gloves. Iodine is here on the periodic table, group 7, that's the halogens, and we know that sodium chloride we've got here is also in that same group, and we know that it forms an ionic bond between sodium and chlorine, and we know that an ionic bond means that it will fall apart when we put it in water, and we know that it's soluble in water. So I'm not going to bother to try that. I'm going to use the salt that we've got and see if that will be soluble in our oil. I am taking predictions, but doesn't seem to have been a lot of uptake. Okay, this is olive oil, product placement. Okay, I'm giving this a really good shake. It looks like a horrible mess. And definitely not dissolved. Okay, iodine, this is I2, remember? That's the natural state that it's found in. You've seen this before, we did this when we did the sublimation. I'm going to drop this into some water, so here's distilled water. And I'm taking bets. Now you can say, hang on, iodine is in the same column, same group here, so it has the same properties as chlorine. Chlorine we know forms an ionic bond. Ionic bonds are soluble in water. So there we go. I'll give that a good shake. Okay, and you see still a couple of lumps, just the 2 lumps on the bottom, not soluble. Okay, soluble in oil. I hear some people say, yes, it will be soluble in oil because it is a covalent bond, because the pulling power of each iodine atom will be the same. And so the bond must be covalent. If it's a covalent bond, let's just put a little bit more in. If it's a covalent bond, then yes, it will be soluble in oil and not in water. So when we're talking about this, remember we're talking about the sharing of electrons. So I'll give this a really good shake. This oil is actually quite dark, and so it might be difficult to see. Okay, it doesn't look as though it's going to dissolve in that either. I've got some paler oil though, which might be easier to see. So this is some cheaper oil, not the olive oil. I'll give it a go. Okay, I think you can probably see, if I hold up this against the white here, you can probably see that this is slowly dissolving. There's quite a bit of iodine in there, and you can see that the oil has definitely changed colour. Even my olive oil has definitely got darker. We'll carry on giving this a shake. Now the reason for this is because they have to share electrons nicely. Even if this wouldn't share electrons nicely if it was with sodium, and in your iodized salt that you get in New Zealand, it's partly sodium chloride and partly sodium iodide. So this has exactly enough pulling power that it would form an ionic bond if it were with a metal, but because it's with another iodine atom, they both have equal pulling power, and so they're both tugging equally on that shared electron, and that makes it a covalent bond, and that makes it insoluble in water. So there's my water, not soluble. I'm going to pour this water on top of this oil, which will help you to see the difference. And you might think again, well, why do we care? We care a lot because different cells in our body and different constituents of our body are soluble with in different things, and different solutes are soluble in them. And it all depends on how much of a share of those electrons it gets. And I think you can see, if I shake this up, it will take a while to settle out. So I think we might have to come back and see this settled out, and you'll be able to see that all of the colour is in the oil and not in the water. It'll take a while to settle out, so I might have to add a photograph in about 10 minutes time. Okay, I hope that sorted that experiment for you. I've included the linear bent because of course we care. By the time we come to a molecule like this, we're not going to try and name the shape of this. Too complicated to care. Okay, ka pai.